Hello everyone and welcome back to our videos. Today we will talk about the position and warning systems on the aircraft. AIRFRAME book chapter 10, and we will start to talk about the anti-skid brake control systems because it's the most important for make the aircraft safe at the landing. Anti-skid brake control system. It's important that a pilot avoid excessive braking to prevent skidding and loss of control. Modern high-speed jet aircraft usually have more than one wheel on each side, and all of the brakes on one side are controlled with one pedal. With this arrangement, the pilot has no way of knowing when one of these wheels begins to skid. Without prompt corrective action to release a locked up wheel, the tire is likely to blow out and damage the aircraft, or in severe cases result in loss of control. How aircraft stop? The aircraft stop by friction created by the brakes reduces the wheel rotation rate, and friction between the tire and the runway slows the aircraft. You have to take this note. If the tire rotation slows too rapidly, the tire will begin to slip on the runway instead of grabbing. Once the tire begins to slip, a skid soon develops and braking effectiveness decreases rapidly to near zero. This is the idea how the brake system or how the anti-skid brake control system works. System operation. You use a simple form of manual anti-skid control when driving on ice. For the most effective stopping, you pump the brakes. They are applied only enough to slow the wheel, then released before the wheel decelerates enough to lock up. This method only works well when the control valves are capable of operating very quickly. As we see here in this figure, we have the point A, B, C, and D, while the speed of the wheel decreases. At the point A, the brakes are applied and the pressure rises until the wheel starts to slip, but not skid. At the point B, sufficient pressure is soon reached to produce enough friction in the brake to cause the tire to start to skid on the runway. At the point C, the wheel has completely locked up even though the pressure continues to drop. At the point D, the pressure is low enough for the friction between the tire and the runway surface to start the wheel rotating again. A successful anti-skid system requires two features that early on and off systems did not have: the wheel speed sensor that can detect a change in the rate of deceleration and send a signal for the pressure to be released before the wheel gets deep into a skid. A valve is also needed that acts quickly enough to prevent all of the pressure from being released before the next application of the brake. When the pilot wants to stop the aircraft in the shortest distance possible, it's necessary to depress the brake pedals all the way to induce maximum braking, so all of the brakes receive the maximum pressure. If any wheel should decelerate at a rate indicating an impending skid, some of the pressure to that brake is dumped into system return manifold. The control circuit then measures the amount of time required for the wheel to spin back up and applies a slightly reduced pressure to the brake. If this reduced pressure again causes a skid to develop, the cycle is repeated. When the airplane slows down to approximately 20 miles per hour, mph means mile per hour, and there is no further danger for skidding. What will happen? The anti-skid system, of course, automatically deactivates, and this gives the pilot full control of the brakes for maneuvering and parking. So that will give an indication to the anti-skid system that the aircraft in safe mode. There isn't skidding, so our system it will deactivate.